Section 4.4, graphing sine and cosine functions. I got the split screen on, so here we go. We're going to graph y equals sine of theta. We have our common angles, pi over 6, pi over 4, pi over 3, and we're working our way around the unit circle. And we have the decimal values for each of the signs of the angles. For example, this is the decimal value for square root of 2 over 2. This is the decimal value for the square root of 3 over 2. And this is, well, that's the decimal value for 1/2, of course. So let's graph sine, and we're going to put the angles on the x-axis, and we're going to put the values on the y-axis. The sine of 0 is 0, and then we go to 0.5, 0.7, that's the 0.71, then the 0.86, and then at pi over 2 we're up to 1, and then we come back down in the same manner, 0.86, we have the 0.7, the 0.5, and then at pi, sine is 0. So we have this arch right there like that. And then we go to negative values. So we have negative 0.5. So negative 0.5, and then the 0.7, the 0.86, and we're down to negative 1. So then sine looks like that. Well, we're going to go negative, but we're going to work our way back to the x-axis. So here are our negative values. So we go to negative 0.86, negative 0.7, negative 0.5, and back to 0. Well, sine is a wave. So here's one complete wave of the graph of sine. Now, if we use a graphing utility, we get this nice smooth curve. Let's do the exact same thing for y equals cosine of theta, and we're going to get the same values because we used the same the values for x and y. So we have the square root of 3 over 2 here. Here's the square root of 2 over 2, and this is the 1/2. But cosine starts at 1. It does not start at 0. So then we have the cosine starts at 1, not at 0 like sine does. Then we have the 0.86, the 0.7, the 0.5, and then we're back down to 0 at pi over 2. Then we go negative 0.5, negative 0.7, negative 0.86, back down to negative 1. And then we're going to go back towards the x-axis in the same manner. There's the 0.5, and we're back to 0 at 3 pi over 2. So there's part of the wave, and we have to finish one complete wave when we get back to 2 pi. So there's 0.5, 0.7, 0.86, and to positive 1, right back where we started. If we use a graphing utility, then we get this nice smooth wave starting at 1, and then this is one complete wave when we get back to the same place. Properties of the sine and cosine functions. We have sine function. The domain is negative infinity to infinity, and the range is negative 1 to 1. So sine will never get higher than positive 1, and it'll never get lower than negative 1 unless we do a transformation. The y-intercept is 0. X-intercepts are at multiples of pi. So this will cross the x-axis at 0, pi, 2 pi, 3 pi, 4 pi, and so on. Continuity, continuous on negative infinity to infinity. It is symmetric about the origin, which means it's going to be an odd function. So if you pick a value on the right side of the origin and go through the origin, you should have the corresponding point on the graph. The extrema, we have maximum at 1 at pi over 2, and then plus every 2 pi n. So we have a maximum here, and we'd have to go a complete wave to get to the next maximum. Minimum of negative 1 starting at 3 pi over 2, and then happening every 2 pi. Behavior, limit as x approaches negative infinity, and infinity does not exist. There's no limit, because this just keeps going up and down forever. It's never really leveling off to anything. And this oscillates between negative 1 and 1. Cosine function is very similar. The domain is negative infinity to infinity, range negative 1 to 1, but the y-intercept up here is at 1, not 0. The x-intercepts, this happens to be wrong. This is wrong in your book. The x-intercept happens at pi over 2, certainly, but not every multiple of pi over 2, because pi is 2 pi over 2. So the x-intercepts happen at 1 pi over 2, 3 pi over 2, 5 pi over 2, and so on. Now those are the odd multiples. So we have pi over 2 times 2n plus 1. That makes it an odd number. If you multiply anything by 2, that'll make it even. Add 1, and now you have an odd number. So it's odd multiples of pi over 2, not every pi over 2. Your book is wrong. The continuity, continuous everywhere. Symmetry, the y-axis. Cosine is an even function, so it's reflected across the y-axis. Maximum of 1 at multiples of 2 pi. So that'll happen at 0, at 2 pi, at 4 pi, at 6 pi. Minimum of -1 at pi, and then 2 pi after that. So the minimum happens at pi, and then 3 pi, 5 pi, and so on. Amplitudes of sine and cosine functions. The amplitude of a sinusoidal function is half the distance between the maximum and the minimum values of the function, or half the height of the wave. So you could say, well, it is from the amplitudes from midline to the crest, or midline to the trough. Or you could go from trough to crest and just divide that by 2. For y equals a sine of bx plus c plus d and y equals a cosine of bx plus c plus d, the amplitude is the absolute value of a. So if we have y is equal to 2 sine of theta, the amplitude is 2. If it said -2 sine theta, the amplitude is still a positive 2. Describe how the graphs of f and g are related. Then find the amplitude of g and sketch 2 periods of both functions on the same coordinate axes. So f of x is cosine of x, and g of x is 1/3 cosine of x. Well, that's just multiplying the function by 1/3. That's your transformations. So g of x is f of x shrunk vertically by 1/3. And the amplitude of g of x is 1/3. So when we graph f of x, we're going to have to go up to 1 and down to -1. But for g of x, we will only have to go up to 1/3 and down to -1/3. Now when we graph sine and cosine, we don't plot all those points we did before. We only have to worry about the 4 corners of the circle is what I call it. And I know circles don't really have corners, but if you look at the unit circle, we're going to plot points at 0, pi over 2, pi, 3 pi over 2, and then 2 pi, and we'll play connect the dots knowing that it's a wave. So we have 1, 2, 3, 4 points. We'll call this 2 pi. This is pi. We have pi over 2 and 3 pi over 2 here. And then going backwards, we have 1, 2, 3, 4. This will be -2 pi. Half of that is negative pi. Negative pi over 2, and we have 1/2, 2/2, -3 pi over 2. Now we can graph cosine. Cosine starts at 1, then by the time we get to pi over 2, it's at 0. Then we go to -1, back to 0, and back up to 1. And you can look at one of the first things we did when we graph sine and cosine. This is exactly what's happening, but when we connect the dots, it's a wave. Now going back to the left, we go 0, -1, back to 0, and up to 1. So here is 2 complete waves of cosine. And then we're asked to graph g of x also. Well, g of x is very similar, except it only goes up to 1/3, and it only goes down to -1/3. Otherwise, it's pretty much the same wave. So the amplitude is not as big. And then we go back the same way, down to -1/3, up to 0, and then up to 1/3. Describe how the graphs of f and g are related. Find the amplitude of g. Sketch 2 periods of both functions on the same coordinate axes. So now g of x is f of x stretched vertically by 5. And the amplitude of g of x is 5 in this case. So now f of x is only going to go up to 1, but g of x is going all the way up to 5, and it will go down to -5. F of x is only going to go up to 1 and down to -1. So we have 1, 2, 3, 4 marks. There's 2 pi. There's pi. And we go back to the left to get 2 full periods. And so we have negative 2 pi here and negative pi here. So to graph sine starts at 0. It goes up to 1, back to 0, down to negative 1, and back to 0. So there's one complete wave of sine. We go to negative 1, 0, up to 1, and back to 0. So there's two complete waves of sine. And now we have to graph g of x. And g of x will start up at, well, no, it'll start at 0, then go to 5, back to 0, down to negative 5, and back to 0. Yikes. This should be a very smooth wave. Sometimes these tablets they're hard to graph sometimes. Maybe I'll slow down a little bit. So let's try to get some sort of decent wave here. Down to negative 5 and back to 0. If a is less than 0, the graph of the sinusoidal function is reflected in the x-axis. Well, if you have y equals negative sine of x, that takes sine of x and reflects sine over the x-axis. So sine starts at 0, goes up to 1, but negative sine of x will start at 0 and go down to negative 1. Describe how the graphs of f and g are related, then find the amplitude of g of x and sketch two periods of both. So we have cosine here. G of x is f of x stretched vertically by 4 and reflected over the x-axis. Let's graph cosine. Cosine goes up to 1 and down to negative 1. Here's our 1, 2, 3, 4 marks. We'll make this 2 pi. And we have 1, 2, 3, 4 marks to the left. That's negative 2 pi. And then cosine will eventually go up to 4. So we'll make this 4 and down to negative 4. Cosine starts at 1, then goes to 0, down to negative 1, back to 0, and up to 1. So there's cosine, one period of it, and here is two periods of cosine going to the left. And now we have to graph negative 4 cosine of x. Well, normally cosine would start at 1, multiply it by 4, that means it starts at 4, but then multiply it by negative, that puts us down here at negative 4. And then it goes to 0, up to 4, back to 0, and we end down at negative 4, right where we started. So let's attempt to make a smooth curve for this. And then on the other side, we'll go to 0, up to 4, back down to 0, and finally down to negative 4. Periods of sine and cosine functions. The period of a sinusoidal function is the distance between any two sets of repeating points on the graph of the function. So if we are approaching this point from above, the full wavelength or the full period will be when we get to this point from above again. So getting to this point is not one complete wave. Getting to this one is from above. Now normally we use the crest or the trough to determine the wavelength or the period. Describe how the graphs for y equals a sine bx plus c plus d and y equals a cosine bx plus c plus d, where b does not equal 0, the period is 2 pi over the absolute value of b. So we're looking for the value in front of x. 2 pi over the absolute value of b. So we report the period as a positive, never as a negative value. Describe how the graphs of f and g are related, then find the period of g of x, and sketch at least one period of each function on the same coordinate axes. So we have cosine of x and cosine of x over 2. Well, the period of a function, of a trig function, is 2 pi divided by what's in front of the x. And here we have 1/2 x. So we're taking 2 pi divided by 1/2. That's equal to 4 pi. g of x is f of x stretched horizontally by 2. Remember, when we are on the inside of a function, we have to think backwards. So remember, when we're on the inside of a function, we have to think backwards. So 1/2 x stretches horizontally by a factor of 2. So now we have 1, 2, 3, 4 marks. That's going to be 4 pi. But then we'll need 1, 2, 3, 4 marks to graph cosine, which only goes to 2 pi for one complete wave. Both of them are going up to 1 and down to -1. So here's cosine of x. We're going to graph cosine of x. Cosine starts at 1, goes down to 0, -1, 0, and back to 1. So now we've taken that wave and we have stretched it horizontally. So now when we graph cosine of x over 2, we do start at 1, but then we are at 0 at 1 pi, at -1 at 2 pi, at 0 at 3 pi, and then back to 1 at 4 pi. So this graph stretches the original horizontally by a factor of 2. Graph the following. We're going to reflect over the x-axis, stretch by 3, and we have a new period for this one. 2 pi over 2 is the new period. It's 2 pi over the b, I think they called it. Sometimes we call it k. And so the new period is pi. 1, 2, 3, 4. That's pi on the right. 1, 2, 3, 4. That's negative pi on the left. Sine starts at 0 and then goes up to 1, but in this case, we're going to start at 0 and we're going to go down to -3. We're reflecting over the x-axis and we are stretching vertically. So we go to -3, 0, 3, and then back to 0. There's one complete wave right there. And we'll try to make nice and smooth curves. And then going back the other way, we're up at 3, 0, -3, and then 0. So there's two complete waves of sine. Negative cosine of x over 3. Well, let's get the period first. We have 2 pi over 1/3, which is 6 pi. So we're going to make the fourth mark, 1, 2, 3, 4. That's 6 pi. So this would be 3 pi, and this would be 3 pi over 2. So 3 halves, that'd be 6 halves. This would be 9 pi over 2 if we wanted to label every mark. 1, 2, 3, 4. This is -6 pi. So this is -3 pi. Now, these graphs are not the same length. They're not the same width. If you go from 0 to pi, that is not the same as 0 to 6 pi. This is a much longer wave. But in order to make the graphing as easy as possible, we just find the period and make the fourth mark that value. Cosine is going to go up to 1 and down to -1. And normally cosine would start at 1, but we are reflecting this over the x-axis, so now this graph is starting at -1. And then now has a period of 6 pi. So we go to 0, up to 1, back to 0, and down to -1. And then we do the same pattern on the other side.